Hi guys, it's me, Mr. Bertoch, your incredibly handsome, horrific science teacher. And in this video, we're going to learn about molecules. In another video, I talk about atoms and how they make up everything, pretty much. All of matter in the universe is made up of these little atoms. And we talk about in that video what atoms are, that they're made up of protons, neutrons, and electrons. So now we're going to look at how atoms combine to form molecules and how molecules make compounds, or how compounds are a bunch of molecules. So in the same way that an element, and remember we learned that there's more than 100 elements, in the same way that an element is made up of little atoms, molecules, compounds are made up of little tiny molecules, and molecules are atoms that are stuck together. But pray tell why? Why do atoms stick together like Legos to form molecules? So that's what we're going to look at in this video. By the end of this video, your goal is to understand why molecules snap together why atoms snap together and form molecules. In order to understand why atoms stick together, we have to back up a little bit and talk just a little bit more about atoms. So we're going to talk a little bit more about atoms than I do in the atom video. Okay, and we're going to look at how electrons orbit the nucleus of an atom. So if you'll recall from that video, and if you didn't watch it, you can go watch it, that an atom is made of protons, neutrons, and electrons. And protons have a positive charge, and electrons have a negative charge, and neutrons don't have a charge. They're the glue that hold the protons together. Okay, so I have in the nucleus of an atom, I have protons and neutrons that are sitting together, and then I have electrons that are orbiting around and around and around and around forever the nucleus. But those electrons, as they orbit around the nucleus, they don't do that randomly. There are certain rules that they follow, like traffic laws that they have to follow, or they will get a ticket, but they don't really get a ticket because they never break the rules. So the electrons are orbiting around the nucleus in what we call either orbitals or shells. You can kind of think of it like a mini solar system. And the words orbitals and shells aren't always used the same way. They have slightly different meanings, but for the purpose of what we're going to talk about right now, we're not going to go into the level of depth that you might go into if you were like in a physics class. So it's okay. We're going to use them interchangeably. Okay, so you could say either orbital or shell, and you'll be fine. Okay, so the orbitals, or the shells, can hold a certain number of electrons. The first orbital holds, and you need to remember this, you need to rememberinate this, stick it in your brain and hold it there forever. The first orbital can hold 2 electrons, and that's all. So the first 2 electrons of an atom are always going to end up on the first orbital, and it's just going to be 2. So, and that would be hydrogen and helium, because hydrogen has 1 electron. Its atomic number is 1, so it has 1 proton and 1 electron. Helium has an atomic number of 2, so it has 2 protons and 2 electrons. Okay, so in the case of hydrogen and helium, it only has one orbital, and both electrons are on that first orbital. The second orbital, once the first orbital is full, then we start using the second orbital. The second orbital can hold up to, ready? Drum roll. You want to memorize this as well. It's not 2 anymore. This time it's 8. The second orbital can hold up to 8 electrons. Hooray! And the third orbital can hold up to 8 as well. And we're going to stop with the third orbital because it gets a little more complicated after that. That's beyond what I want to talk about in this video. But the first orbital holds 2 electrons, the second orbital holds 8, and the third orbital holds 8. So that gives you up to how many? 8 plus 8 is 16, plus 2 is 18, right? So that lets us get all of the elements that have an atomic number of 18 or less, that we can now understand how the electrons are orbiting around the nucleus of those atoms. Okay, so for example, oxygen has an atomic number of 8. And so an oxygen atom is going to have 8 protons and 8 electrons. Well, the first 2 electrons are going to orbit on the first orbital, and that leaves 6 more electrons. Where are they going to go? They're going to go on the second orbital. So there'll be 6 electrons on the second orbital. So if we were to draw an oxygen atom, you would draw 8 protons in the nucleus and some random number of neutrons to hold the electrons together. Then you would draw 2 orbitals. You put 2 electrons on the first orbital and 6 electrons on the second orbital, like a little solar system, with 2 planets on the first orbit and 6 planets on the second orbit. Okay, so that's how electrons orbit. But why do they want to form molecules? Well, here is the dealio. The electrons don't like having empty shells or empty orbitals. It bothers them. They're like, but I need to accessorize. I need to wear my bestiest electrons. They don't want to go out in public without all of their electrons. It makes them feel, I don't know, uncool or whatever. So they want to wear more electrons than they're supposed to. So oxygen has 6 electrons in its outer shell, but the outer shell has room for 8. That leaves 2 extra spaces. And oxygen is like, yeah, I know I only have 8 protons, and so I should only have 8 electrons, but I have 2 more spaces on my outer shell. So I'm going to like share electrons with some other atom. And that is how they form molecules, because what happens is atoms that have extra room on their outer shell, where there could be another electron, but isn't because there's not enough, that atom doesn't have enough electrons to fill its outer shell, well, they'll share with each other. For example, consider water. What is water? Besides a delicious and refreshing thing that you drink when you are thirsty, it's water is, and you know this, it's probably the most familiar chemical formula that you'll ever encounter. It's H2O. H2O. Well, what does H stand for? H stands for hydrogen, and the 2 means that there are 2 hydrogens. Okay, 2 hydrogen atoms, and O stands for oxygen. So a molecule of water is nothing more than an atom of oxygen snapped together like Legos with 2 atoms of hydrogen. And that's all water is. Hydrogen is a gas. Oxygen is a gas. We breathe oxygen, okay, obviously. Hydrogen, doesn't really harm us if we breathe it in. It's in the atmosphere in very trace amounts. So these 2 gases snap together like Legos to form H2O, water, and now they're totally different. Now they're water. They're a liquid. different color, different texture. They behave differently in the environment simply because they have joined together. They're something now, a totally new type of substance. Okay, let's look at the relationship between those atoms so we really understand why they are snapping together. So hydrogen has one, it's got atomic number 1, so it has 1 electron. And that outer shell, the first shell, but it's the outer shell for hydrogen, wants to have 2 electrons, but it only has 1. Oxygen has 8 electrons, so the outer shell has 6, as we talked about a second ago. So that leaves 2 empty gaps. Well, notice that hydrogen and oxygen can share an electron, and that gives hydrogen 2 electrons and oxygen, well, 7. But then another hydrogen sticks to it, and it also shares an electron with that one. And so now that one also has 2 electrons, and now oxygen has 8 in its outer shell. Okay, and so now all of the electrons, or rather all the atoms, are happy. They're like, hooray, I have all of my electrons. And technically hydrogen still has the right number. It has 1, but it's sharing 1, so it has 2. And technically oxygen still has the right number. It has 8, but because it's sharing 2 with those 2 hydrogens, it now has 10. It kind of sort of has 2 extras, and they're all happy. So they've stuck together in using those empty slots to snap together like Legos, and they have formed a molecule. That is called a covalent bond, and that's an important word, a covalent bond. Okay, and whenever a covalent bond occurs, we call the resulting substance, well, the entity, we call it a molecule. The substance we call a compound. So a whole bunch of molecules is a compound. So water is a compound because water is made up of molecules. Hydrogen is an element and oxygen is an element because they are made up of pure atoms. There is another way that, one more way that atoms combine, and it's called ionic bonds. Now, ionic bonds are a little bit different. Ionic bonds form when one of the atoms is selfish and it steals the electron from the other atom. So an example of this would be sodium and chlorine. Okay, sodium and chlorine, this is a famous example. This is pretty much the example that will be used by all science teachers everywhere because it's a really great one, because it's kind of cool. Because here's the dealio. Okay, sodium is a poison and chlorine is a poison. And yes, we use it in swimming pools, but we use it in very small amounts. And we use it in swimming pools because it's a poison. And so it kills all the germs, all the bacteria and viruses and stuff in the pool. But we use just drops, not very much, so that it doesn't harm people. But if you had pure chlorine and you like breathe it in, it would not be a great thing. Okay, same with sodium. It's impure, it's dangerous, it's deadly. But sodium and chlorine combine and they form a totally different thing that we eat all the time, which is salt, table salt. Okay, but they don't share electrons. They combine in a little bit different way. So what happens is that the chlorine is like, you know what? I'm just going to steal your electron from you, sodium, and you can just give it to me. You don't need it. And so there. And so chlorine takes an electron from sodium, just takes it. It leaves sodium one less electron, and it gives itself an extra electron, one more than it should technically have. But because it does that, electrons have a negative charge, right? And so now that chlorine atom has a negative charge because it has one more electron than it has protons. So that gives it a negative charge. And the sodium has a positive charge because it's short one electron. So it has one extra proton. So now you have a negative and a positively charged atom. And so they just kind of stick together because they're like a balloon sticking to a wall. They're got different charges. The chlorine atom has a negative charge. The sodium atom has a positive charge, and so they just kind of stick together. They kind of hang out. They're not sharing electrons. They're not bound together by a shared electron, as in a covalent bond, but they're just kind of stuck together like a balloon sticking to a wall because of their positive and negative charges. Technically, we don't call them molecules. It's okay if you do, but technically we call them ions. And I know that we talked in the atom video about ions as well, and we do refer to individual atoms with a negative charge or a positive charge as ions. We also refer to molecules, but they're not really molecules, that are made this way with ionic bonds. We call them ions. So salt, table salt, is an ionic bond. It is a compound that is made out of ions. And that pretty much explains how substances, atoms combine to form molecules and to form compounds. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.